Hey guys, welcome back to Genius Learning. So let's take a look at one of my favorite problems. This is a very common problem in Physics 1. Great example of conservation of energy. So here we have a roller coaster. All right, and the beginning of the roller coaster is released from rest. So initial velocity is equal to 0. Okay, that means that here is the roller coaster starts at 50 meters above the ground at point A, right? Point B is on the ground, so there's no height. Point C here shows that the velocity has reached 20 meters per second at this point at a height that's unknown. And point D is a height of 15 meters, and we'll look for a couple values at that point also. So right here in the roller coaster, this is my favorite seat, right in the front. All right, let's see a couple things that we need to calculate in order to check for the speed of the roller coaster at point B. All right, let's see how fast you can go at this point if you started at 50 meters and velocity initial was 0. Okay, so for part A, and we're gonna use conservation of energy. So conservation of energy, simply, we need to remember one thing, okay? Energy initial, all right, is equal to energy final. So all the energy initially needs to equal the energy final, right? It's transformed into kinetic and potential, and back and forth, but it needs to equal. So with that in mind, let's look at what we have. So what is the speed of the roller coaster at point B? So here, okay? So initially, what kind of energy do we have? Well, we're all the way up here at point A, and we have a height. So let's distinguish between the two types of energies. Okay, so kinetic energy is equal to 1/2 mv squared, and potential energy is equal to mgh. So kinetic energy has velocity, right, which allows you to calculate speed. Potential energy needs a height, okay? And so if we look at the initial height at point A, right, that tells us that, okay, we have potential energy, but right when we started, initial velocity was 0. So we don't have kinetic energy. So for energy initial, we just have potential energy. So we're gonna write mgh on one side equals, okay, so this is the two types, equals, and now final. So our final point that we're interested in is point B. And what kind of energy do we have down here? Well, we have no height, so it cannot be potential energy. And we are going to be going fast, so we are going to have a velocity. So energy final for the point that we're interested in is 1/2 mv squared. All right, and this velocity is at point B. So now we could have also wrote on top right before, we could have put energy gravity, gravitational or potential energy, and energy kinetic. This is another way that you might see it, but this and this mean the same thing. Okay, so now that we have this, right, let's solve for velocity, because that's what we're looking for, right? The velocity at B. So we see that these m's cancel out, right? Because if I divide the m over here, m over m, what are we left with? We have gh is equal to 1/2 v squared. If I pass the 2 to the other side, I'm gonna have 2gh equals v squared, right? Multiplying the 2 to the top over here, and then finally taking the root of both sides to get rid of this 2. So I'm gonna have v, I'm just gonna put it on the other side, and v is equal to the square root of 2gh. And this is for the velocity at B. Okay, so let's put in the numbers. All right, initially we were given the height, which is what we need. We know g is gravity, so we know that we're gonna have velocity is equal to 2 times 9.8 and the height is 50. Okay, so putting that into the calculator, we get velocity at B, I'll denote it with B, is 31.3 meters per second. Remember that that's the units for velocity. Okay, so this is the velocity at B. All right, perfect. So moving on, let's do, now I'm going to put this over here. Now let's do part B. Okay, we have height of point C relative to B. Okay, so height of point C, which is this H right here, relative to B. So we're looking a direct comparison back to B, which was on the ground, and C, which is up here. So let's do part B. We're gonna be looking for the height of point C relative to B. All right, so again, before anything, right when we know we're doing conservation of energy, we start off with always energy initial is equal to energy final, right? Always. Okay, you can even do, instead of trying to guess where everything is at, in other words, instead of trying to understand, oh, energy, what energy do we have here, what energy do we have here, write the whole formula out so that way it's always apparent to you. Energy initial means we're gonna have kinetic energy, right? Initial. Oh, that looks ugly. Okay, plus potential energy initial is equal to, so this whole side here is just for energy initial. You have to have kinetic initial and potential initial. Then you have to do the final energy. So you have kinetic energy final plus potential energy final. Okay, so one more simplification. We know what kinetic energy is, so it's 1/2 mv squared, and that's going to be velocity initial, right, plus mgh. That height is going to be the initial height, right, because we're in the initial side of the equation. Now equals, now we're going to do the final side of the equation, and here we got 1/2 mv squared final, right, so that's the final, and plus mgh height final. Okay, so initial side and final side. Okay, so now we can look at what we need and what we don't have. So first, let's read the question again. The height at point C, right, relative to B. So this is what we're looking for. So it tells us that at C, we know that there's already a velocity. Okay, so we're gonna look at this part here, and we have an initial height. Okay, so we don't have an initial velocity because initial velocity started off here. All right, we're gonna do straight the final velocity, which is VC, because we're gonna calculate this height. So that velocity here is gonna go on this side. All right, so we have height initial that we're gonna keep. So this is 0, right? Because here we're not starting off with a velocity. We're just starting off with, we want to know here the height. So for that, we're gonna use this velocity, this height initial. Okay, we're gonna leave that there. And over here we have 1/2 mv squared final. We do have a velocity, right, final, and mgh final. So obviously this is the one we're looking for right here, the height final. Okay, so let's rearrange everything to have height final in our equation equals something else. Okay, so in other words, let's solve for h final. So what do we have left? We have mg h initial is equal to 1/2 mv squared final plus mgh final. Okay, and so what we're looking for is height final. So the height of point C relative to B. So we're looking for height final. And what's that going to be? We have all the m's cancel out, right? Because we divide by m for everything. And I want to put this whole thing on this side. So I'm still going to keep this. I have g height initial. If I move this over to the other side, it becomes minus 1/2 velocity final squared. And this side stays right there. So that's going to be gravity h final. Okay, so let's do one final step, get rid of the gravity. We're going to divide it to the other side. So I'm going to keep all this on this side the same to make things a little easier. And then I'm just going to divide everything there by g, height final. And that's what we're looking for here. Okay, so we have all the numbers that we need, right? Let's plug them in. So gravity, which is 9.8, right? Height initial. Okay, so height initial was not from B, which is why we made velocity initial 0. We're looking from here, right, to here. So the height of C relative to B, right, which is this one, but we have to do the energy from the initial to the final thing that we're looking at. So don't let that confuse you. Because this says relative to B, that just means that, you know, we're looking at the height that corresponds from here to here. But always when we're doing initial energy and final energy, we have to look at the initial energy. And the initial energy, we did not have velocity initial because it was 0, right? We have an initial height, which is 50, so that this side is good. And now this side here corresponds to everything that's here at C. We have a velocity final, yes we do, and height final, that's what we're trying to find. So in other words, everything here on this side corresponds to point A, and everything here on this side corresponds to point C. So energy initial of A, energy final of C, okay? So we're gonna bring that down and we're solving now, right? This got canceled out. We have all these values and we're solving for height final, okay? What is height initial? Well, height initial, 50, right? Minus 1/2 velocity final, which is here. So initial, final, we got 20 meters per second, right? And that's squared, right? And everything divided by 9.8. Okay, perfect. So this is equal to height final. Let's put that in the calculator. And I'm getting 29.6, okay, meters. So the units is meters for height. All right. So again, remember that when we're doing initial energy and final energy, you need to go to initially what happened, what energy we looked at, right? So don't let the problem confuse you by saying relative to B. That's on purpose, you know, but what you need to focus on is the initial energy from the beginning. And then wherever we're stopping at is going to be the final energy. Okay, so now let's take a look at part C and see if we can tie in the rest of this. Okay, so for part C, I won't be able to see it here, but let's, okay, so for part C, we want to know the speed at point D. So that's for part C, okay? So now let's take a look. Again, what do we start with, right? We're using conservation of energy. We want to know the speed here, right? We know the height, but we don't know the speed. So first of all, before anything starts, conservation of energy equation, right? Energy initial is equal to energy final. And to be a little more specific, right? Energy initial at point A, right? Circle that, is equal to energy final at point D, because those are the two things that we're interested in. We're always gonna start at A. So this is just like the previous one, we started at A, right? All three of them, we started at the initial, and then wherever we're looking at is gonna be our final energy. Okay, so now, again, here we have 1/2 mv squared initial plus mgh initial, right? That's for this side, equals, now we're gonna do the final, 1/2 mv squared final plus mgh final. All right, so let's figure out what we have and we don't have. So again, at point A, right, we know that velocity initial was 0, so this goes to 0, right? Velocity initial 0, and we do have a height, so that stays. Velocity final, well, that's what we're looking for, because that's the speed at point D. So this right here, velocity final, is what we're looking for. And mgh, h height final, we do have a height final at D, so we have everything we need. So now let's bring it down. We have mgh initial is equal to 1/2 mv squared final plus mgh final. Okay, let's cancel out the m's, and we're solving for velocity final, right? So let's take this and move it to the other side, right? I'm gonna rewrite this, gravity height initial, then I'm gonna move this over to the other side of the equal sign, so it becomes minus because it's positive, right? So g gravity height final, right, equals, now what's left on this side of the equation is this here, which is 1/2 velocity final squared. All right, let's get rid of that 2. So we're gonna multiply the 2 to the other side. So I'm just gonna put 2 in parentheses because it goes to the top, and then I'm just gonna rewrite everything that we have here, right? Height final equals velocity final squared. So what I did was multiplied, so the 2 is on the bottom here, multiply it to the top on this side, right? And so then I put it in parentheses so it can distribute back into both. Okay, now all we need to do is take the root. So let's take the root both sides. So v final, I'm gonna write it on the other side, is equal to the square root of, and just write everything that's there. So everything that's there. Okay, so the square root both sides to get rid of that, that's 2. And now we have the velocity final at D, right? This is at point D, okay? And we have all the variables, all the numbers for this, so let's figure this out. Velocity final, right, is equal to the square root of 2, we know gravity, it's 9.8. Height initial of the initial energy, so don't forget that. The initial energy, which is gonna be 50, minus 9.8 for gravity, and height final, which is the point of interest, which is D, the height is 15. Okay, make sure everything is in meters, so everything's good. And that's it. So now putting this into the calculator, we get that velocity final at point D is gonna be 26.2 meters per second. So this is at point D. Okay, so let's so recap for just real quick here. We got, so for part A, right, we're gonna do the speed of the roller coaster at point B, right? Energy initial, energy final. Remember that it's energy initial at A and final at B. So all the energy associated with point B, which is on the ground, so there's no potential, there's only kinetic, and here initially we have potential, but no kinetic because it's starting from rest. Okay, so we plug that in and we solve for velocity at B and we're good. All right, same thing here. Now we're looking for the height of point C, so this height right here, and we start with our equation again. Energy initial is equal to energy final. Energy initial of A, so where was the energy initially started, and C, now the point of interest. So we work out what we have, what we don't have, solve, and we get height at point C. And finally, again, now we want the speed at point D, energy initial, energy final. It's a beautiful equation, simple, right? We start off at A and end at D. So all the energy associated here goes on this side, final, and all the energy associated with the initial goes on the left side, right? There's no initial velocity. And when we solve it out, we're looking for final velocity at point D, and we're good to go. All right, one of my favorites there. So hopefully you like that, and we'll work on some more conservation of energy problems, guys.